At a busy port terminal, workers stand near a flatbed trailer as a crane lowers a suspended load. During positioning, the load begins to move out of alignment. Never stand beneath or remain close to a suspended load. Suspended loads are subject to unpredictable movement caused by rigging conditions, balance, wind, or equipment motion. In a material yard, a forklift operator attempts to elevate a large cylindrical steel component, but the lifting didn't go as planned. Never attempt to lift a load that exceeds the rated capacity displayed on the data plate. Forklifts operate on a balance principle, using the rear counterweight to offset the lifted mass. When load weight and distance exceed design limits, the overall stability range is reduced. Always verify load weight and dimensions before lifting. If steering response changes or rear wheel contact begins to reduce, stop the operation immediately and lower the load. Inside a tire service facility, a worker handles a large truck tire, treating it as unpressurized. As it drops onto the concrete, the tire reacts unexpectedly. Never release or handle an inflated tire abruptly. Heavy vehicle tires contain substantial volumes of compressed air constrained by internal steel reinforcement. Over time, internal components may be affected by age, environmental exposure, improper inflation, or prior handling. Sudden external forces can transfer stress through the internal structure, increasing the internal pressure response. Always handle inflated tires as energy-managed components rather than passive objects. Lower them gradually using a tire dolly, hoist, or mechanical assist. Prevent tires from contacting hard surfaces abruptly. In a narrow excavation trench, workers operate alongside an existing concrete wall. After a few seconds, the wall begins to shift. This scenario demonstrates excavation undermining risk. When soil is removed adjacent to a wall or foundation, the lateral earth support that previously stabilized the structure is reduced. Gravitational forces then act on unreinforced material. Without engineered shoring, underpinning, or reinforcement, environmental factors such as vibration, moisture changes, or nearby equipment movement can influence structural alignment. Before excavation begins, evaluate nearby structures and install engineered shoring or underpinning as required. Maintain appropriate soil slopes or benching based on soil classification. At a residential foundation site, a concrete pump boom extends overhead to access the pour location. During the operation, the boom develops a structural fault. Never position yourself within the vertical operating zone of an articulating boom. Pump booms operate using high-pressure hydraulic systems and experience repetitive loading cycles. Over time, components such as hoses, pins, welds, and joints experience wear. Changes in system behavior can result in unexpected boom movement within its operating range. Establish a clearly defined exclusion zone beneath the boom's working area. Only essential personnel should approach the discharge hose, and they must remain outside the vertical travel zone. Conduct daily inspections of hydraulic lines, pivot points, and structural welds. Any irregular movement, sound, or hydraulic seepage should prompt immediate shutdown and evaluation. Inside a battery manufacturing facility, a maintenance worker is raised using the forks of a forklift to access overhead equipment. During troubleshooting activities, the industrial system returns to an automated operating mode. This represents a breakdown in energy isolation procedures combined with improper access equipment selection. Industrial machinery operates through automated control systems that function independently of human presence unless physically isolated. Without proper lockout procedures, sensors, timers, or programmed logic may enable equipment operation. Always apply complete lockout. Procedures by isolating the primary energy source and securing it with a personal lock. Confirm zero energy status before beginning work. Use approved access equipment such as scissor lifts or certified work platforms. Forklift forks are not designed to provide stability, fall protection, or controlled access for personnel. On the rear deck of a transport vehicle, a worker organizes equipment while a concrete utility pole is lifted overhead. During hoisting, the load becomes unstable. Never remain on a vehicle while a load is being lifted within its operating envelope. Rigging components such as slings, chains, and hooks are subject to wear, environmental exposure, and cumulative loading that may not be visually apparent during routine handling. Enforce a strict clear the deck policy during all lifting operations. Personnel must exit the vehicle before hoisting begins and remain clear until the load is fully secured. Inspect all rigging components for abrasion, deformation, and hardware wear before use. In a transport maintenance yard, a mechanic tries to manually fit a heavy steel rim into a truck tire. As the force is applied unevenly, the rim suddenly moves. Rubber temporarily stores energy when compressed and gradually returns that energy when resistance changes. When combined with rigid steel components, reactive forces can occur if installation methods rely on uneven pressure or impact-based techniques. Use controlled progressive installation techniques at all times. Employ tire mounting stands, appropriate tire tools, and approved bead lubricants to minimize resistance. Avoid impact-based methods entirely. In an active production facility, a worker reaches into a molding machine to reposition a tray. The machine suddenly begins its automated cycle. Never reach into a machine unless power is fully isolated. This represents a blind machine condition. Safety devices such as light curtains and interlocks rely on proper alignment and sensor clarity. When these systems are obstructed, misaligned, or compromised, detection capability may be reduced. Verify safety devices at the beginning of each shift by conducting functional checks. If a sensor does not stop the machine as intended, remove the equipment from service immediately. Follow lockout, tagout procedures by shutting down the main disconnect. At a grain handling facility, a worker stands near the intake section of an inclined conveyor while loading sacks. Loose clothing interacts with the moving belt surface. Conveyors generate a continuous pulling force at contact locations known as nip points. Once material interacts with a moving belt, force transfer occurs faster than manual reaction time. Require close-fitting clothing when working near conveyors and prohibit loose garments. Install fixed guarding and barriers at intake and return locations. Maintain clearly marked buffer zones around moving equipment, particularly during manual loading. Shut down conveyors before clearing obstructions or repositioning materials. Inside a busy manufacturing area, a pedestrian crosses an open loading zone while a forklift backs up with limited rear visibility. Forklifts have restricted sightlines due to massed assemblies, overhead guards, and counterweights. When reversing, operators may not detect pedestrians approaching the equipment route without clear communication. Physically separate pedestrian walkways from vehicle lanes using barriers, floor markings, and signage. Require operators to sound horns before reversing and conduct full visual scans. Pedestrians must pause at crossings and wait for a clear acknowledgement from the operator before proceeding. To keep learning from these important workplace safety lessons, make sure you subscribe and turn on notifications. Stay aware, stay safe.